Okay, thank you. So today I'm going to talk about a computational approach for quantifying a very important interaction dynamics. It's called behavioral entrainment. Behavioral entrainment has been widely described in behavioral science as a spontaneous and natural behavioral coordination, behavioral accommodation between interlocutors. A very quick intuitive example I like to always give is think about the time when you first meet your best friend, your spouse, or even your advisors. And the time you talk to him or her now, you see how you two are starting to behave similarly. And these are very subtle but very important aspects of human interactions. Many theoretical implications has been proposed for this behavioral entrainment. People have said they use it. Humans use it for achieving communication efficiency. It's a way that shows precursor to empathy, a way for regulating emotion processes in interactions. And there's even people arguing there's mirror neurons in our brain that are trying to govern all of this. While despite there's a lot of evidence in sort of establishing the existence of entrainment, in this specific case, we're going to talk about the vocal entrainment, relatively few words have actually tried to quantify the degree of entrainment. Without this quantification of actually the degrees of entrainment, we cannot really apply this sort of trying to analyze this in a systematic way in this vast domains of human interaction. So for us, we come in and say, okay, how about let's try to quantify vocal entrainment by posing the questions, how much does the two speakers sound alike as they interact with each other? This is not an easy task. Think about the complexity involved in designing a control experiment to actually tackle and try to stimulate these ideas of human behavioral entrainment. And also think about the difficulties having a third person open a human to rate, say on a scale of 1 to 5, how two people are vocally entrained to each other. This becomes a very difficult task due to this subtle nature of this interaction dynamics. We have to go for some unsupervised, completely signal-derived method of computing the similarity between the vocal characteristics. Some more technical challenges. This computing similarity between a time series or signals directly is a pretty classic problem, not just in engineering, also in physics, in business, or in economics. But the problem here is we're dealing with speech signals, and also human has these turn-taking structures. Basically means that the time series that we measure are not simultaneously measured. For each utterance, they can be variable length of time series. And also because of the speech signals, what we do is often calculate multivariate informative acoustic cues. All these challenges the effect of all these conventional synchrony measures like Pearson correlation, mutual information, or coherence measures. And also this entrainment, we can think of it as more of a process, how the people are getting converged. So we like to introduce the idea of directionality. The way we solve this is how about let's take all these multivariate acoustic cues and do a subspace representation to represent the vocal characteristic space of each interlocutor. Then we can directly compute the similarity between the two spaces. Say for a given dialogue in two utterances, we can automatically extract various types of informative vocal features. We can represent the vocal characteristic space using, say, PCA. Now having this two PCA space, we can compute the similarity based on, say, the cosine summation of the cosine angles between the principal components. And because these two are the abstract spaces, we can start introducing the idea of directionality as projecting my features onto your spaces and compute some kind of probabilistic divergence values or similarity measures in that space as a way to quantify how much am I entraining toward you, and vice versa. So what do this completely signal-derived measure mean behaviorally? We have shown that it actually can capture this spontaneous cohesiveness in dialogues in a large corpus of natural and spontaneous dialogue where this should happen, right? In dialogues, people tend to have this cohesiveness. Also, we corrupted knowledge in psychology that people with more positive attitude show a higher levels of entrainment. We can build a prediction model of affect. Now, we also show that it can bring scientific insights into couple therapy, where these measures actually carry significant information about a behavioral dimension that's related to couple therapy outcome. With the availability of this sort of computational framework, we can start systematically using these computational tools and bring other insights into this domains of human interaction studies. Thank you.